Hey guys, Nathan here. Today I just want to do a quick database basics overview about SQL and Microsoft Access database basics. This is a great primer for anybody who is a novice or kind of new to this field of databases. So I think you'll get a lot out of it if you go through this. Basically, this is broken down into two videos, the first half and second half. The first half, the business case for databases, will go over why you would even consider a database. Then we'll go over the key definitions around databases. Then the second video will be an on-screen demo of creating a basic database. One of the first questions that may come up is, what's the business case for a database? Like, when would I use a database versus a spreadsheet? And when do I know that I need to actually switch to a database out of a spreadsheet? Because most everybody on the planet has used Microsoft Excel or some type of similar spreadsheet type application, and we all love our spreadsheets, and so we should love them. But I'm going to show you kind of at what point that stops being efficient and you really need to think about a database. So let's say you have a friend, he runs a garage, and he needs an application to start tracking information about his garage operations. So he comes to you, he asks for help, and the first thing you think about is Microsoft Excel. So you start to load this information into Microsoft Excel. So here we have the vehicles tab, and we're putting information about vehicles being worked on. So these are essentially the customer's vehicles being worked on, and probably need to connect this to the customer some way. So we probably need a customer ID column in here someplace, and we'd hook that to the customers, and then we type in the customers, and here's their ID right here, so we could actually go back to the vehicle and say that one belongs to the first customer, and that one belongs to the first customer, and that actually belongs to the second customer. So we kind of start to organize this in different spreadsheets, which it works pretty good. We got stuff for employees, parts, suppliers, invoices. But and as long as we're entering the data per area, like we're going to put a bunch of invoice data in here, and then the next day we're going to enter a bunch of info about suppliers, we're going to put that all in here, and then we're going to put a bunch of information about the employees. As long as we're working spreadsheet by spreadsheet, everything's fine. But what if we get asked a business question like, tell me any parts over $100 that Carl James here, one of the employees at my garage, has ordered over the last 2 months. And it's those kind of questions where these different spreadsheets have to be combined in order to get the answer, in order to query the answer. It's working across those related tables of data. When you start to realize that a spreadsheet can only do so much, it's really good for holding one table of data and working on kind of one table of data at a time, but it gets kind of tricky when you start trying to answer those type business. That's really when you need to think about a database. The most important definition on this slide is database management system. That's the actual application that's used to run the database engine and access the database tables. The most common ones you're probably familiar with are MySQL, SQL Server, Oracle, and the like. The other thing I would point out on this slide is data integrity categories. The main things you need to think about here are no duplicate rows, enforcing column integrity using data type and format types, referential integrity so that we don't delete related records causing orphans between primary keys and foreign keys, and then any other specific user-defined business rules that come up. Database normalization is essentially the process of decomposing the database into its most logical format so that data can be easily stored and maintained. We are only showing 3 normal forms of database normalization, but there are more than 3, but typically only 3 are used. Under first normal form, we want a table per data grouping. We also want a primary key for each table to track each of the rows in the table. Under second form, we want to remove any duplicated data that would apply to multiple tables and put that in its own separate table. As stated before, we also want to use primary keys and foreign keys to connect tables together. Under third normal form, we want to remove any columns that are not dependent on the primary key column. Typically, we may have 1 or 2 other columns that are actually unique, and that's okay, but if we start having a lot of these, this creates problems. As far as schema goes, there's basically 2 types of database schema, star schema and snowflake schema. The real easy way to tell the difference between a star and a snowflake is that a star schema only has 1 level of dimension tables, while a snowflake will have dimension tables hung off of other dimension tables. So essentially multi-layers of dimension tables. So fact tables versus dimension tables. Fact tables hold a particular business process event and kind of collect everything together. They're kind of like the central hub of a wheel, and as you go out on each spoke, the dimension tables are out on the spoke of the wheel, but the central hub part is the fact table. You can have more than 1 fact table per database, but you usually don't have that many fact tables when it comes to comparing those to the number of dimension tables. They do have all the measurement data in those, like minutes to respond or handle time or those type measurements. Fact tables are hooked to the dimension tables through primary keys from the dimension table going into the fact table as a foreign key. Obviously, for dimension tables, they contain the information pertaining to the objects involved in the business process event or the objects inside the fact table. We're now going to talk about data relationships between tables, and this is extremely important to understand how to join tables together and how to link the data in the database. So the first one we're going to discuss is a one-to-many, and this is the most common. And actually, if you could have it your way, you'd want this to be the most prominent relationship in your database. In this example, you can see in the fact order table, we have multiple orders from the customer Nathan Kellogg. Inside the fact order table, the customer derived ID of 344 is repeated several times, so you know that's a foreign key column. On the table dim customer side, the customer Nathan Kellogg is listed once with the ID 344. So that's essentially how a one-to-many relationship works. With a one-to-one relationship, this is where you have the same number of records in table A versus table B. And you have to ask the question, why would we have this situation? And we should challenge these type of setups because they're not normal in a database. But sometimes you might have a situation like I'm showing here where you have table dim employee and table dim employee restricted, where maybe in table dim employee, which is exposed to most everybody who has read access to the database, they could see employees' last name, first name, and different information about those employees. But table dim employee restricted would be kind of hidden away and restricted to only a very few people, and that would have real personal type information such as social security numbers, performance rankings, and those kind of things. So here's the many-to-many relationship, and this is the worst possible outcome we can have in our database. We want to try to avoid these wherever possible, but sometimes you can't avoid them, and you have to set up a way to deal with these within your database. In this example, I show how several owners own several pets, like the Edwards Frank, Sally, Carl are all owners of the first and second pet listed on the top right table. So the way I've tried to deal with that is put the owner derived IDs in separate columns within the table dim pet, but this is a violation of data integrity rules and something we shouldn't do within the database. The one way I've tried to deal with this in the bottom right table is to push that data into rows, but this also creates a problem where we have duplicate pets. As you can see, the first 3 rows deal with the squirrel pet, the second 3 rows deal with the chipmunk, and then the next 2 deal with the cat, and then you have 1 for the dog. So this is also a violation of data integrity rules. One way we get around this is through a junction table or bridge table, which I'll talk about more in just a few minutes. So now we'll kind of jump over to the second part of this video and actually plan out and kind of build a database real quick so you can see how that works.